Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I commenced and started with chapter number 4, differentiation of vector function, related with FSC part 2 mathematics chapter number 4. In exercise number 4.1, I solved the first two questions already. In today's video, I am going to solve question number 4 related with the same exercise number 4.1, which is the most important question of this exercise. And also for the board point of view, this question is very important. So in today's video we will solve this question number 4. This is totally related with the limits of vector functions. So let's move toward the question. Evaluate the limit of the following expressions. Part number A is limit t approaches to 1. Find the value of 3ti plus e raised to the power 2tj and plus sine phi tk. So we will just apply the limit. Over here t is approaches to 1. So by applying the limit, it becomes 3 into t is 1, so it become 3 into 1i plus e raised to the power 2 into t is 1, so it become e power 2 into j plus sine phi into t is 1, so it become 3 into 1 into i plus e power 2 into 1j plus sine phi into and 1 into k. So 3 multiply 1 will give us 3i and plus e power 2 multiply 1 will give us 2j and plus and it becomes sine pi multiply 1 gives us phi, so it becomes sine time of phi k. So by simplification, it will give us 3i plus e power 2j, and you know that sine pi is actually equal to sine 180, and sine 180 gives us a value 0k. So the required answer will be 3i plus e raised to the power 2j. This is answer for the part number A. Now move to the part number B. It tells that limit t approaches to 0, find the value of sine ti minus tk over t square plus t minus 1. So by applying the limit on the numerator, it becomes limit t approaches to 0, sine ti and minus tk, and also apply limit on the denominator, which is t square plus t minus 1. So it becomes, by putting t 0, so you know that sine 0 gives us 0, minus time of t is 0, so it gives us 0, divided by applying limit in the denominator, so t square, t is 0, so it gives us 0, it gives us 0, we are just left with minus 1. So you know that something divided by 0 minus 0 gives us 0 and divided by minus 1. So 0 divided by something gives us a value 0, so the required and desired answer is 0. Now move toward the part number C. Limit t approaches to 1. Find the value of t cube minus 1 over t minus 1i plus t square minus 3t plus 2 over t square plus t minus 2 into j plus t square plus 1 into e raised to power t minus 1k. Now over here t is approaches to 1. So by putting directly t1 over here, it will give us 1 minus 1 0. Divided by, if I put t1 over here, it become 1 minus 1 again 0. So you know that 0 by 0 is indeterminate form. Indeterminate form, which means it does not mean anything in the calculus and limits. So we will factorize t cube minus 1 using formula a cube minus b cube, which is equal to a minus b into a square plus ab plus b square. So t cube minus 1 will be t minus 1 according to this formula into a square. A is t, so t square plus a is t and b is 1, so it gives us t, and plus b. B is 1, so b square, so 1. So the value of t cube minus 1 will be t minus 1 into t square plus t plus 1 divided by t minus 1 and limit t approaches to 1, and over here we have I, and plus applying the limit on this expression and fraction also, limit t approaches to 1. Over here if I put t1, so it gives us 1 plus 2 gives us 3, and if I put 1 over here, it again gives us 0 in the numerator, and if I put 1 over here, it again gives us 0 in the denominator, again indeterminate form. So I will factorize this quadratic expression and this quadratic expression also. So the quadratic expression of t square minus 3t plus 2 is t minus 1 into t minus 2. So it becomes t minus 1 into t minus 2 in the numerator, and the denominator t square plus t minus 2 quadratic expression is t minus 1. This is the factor t minus 1 and t plus 2. T minus 1 into t plus 2. And also we have j over here. And plus also apply the limit t approaches to 1 on this expression, so it becomes t square plus 1 into e raised to the power t minus 1k. Now over here t minus 1 cancel out with t minus 1, we are left with limit t approaches to 1 on t square plus t plus 1 into I. And plus t minus 1 cancel out with t minus 1, we are left with limit t approaches to 1. In the numerator, we are left with t minus 2. In the denominator, we are left with t plus 2 into j, whole j. And over here, we are left with plus limit t approaches to 1. We are left with t square plus 1 into e raised to power t minus 1 into k. Now by applying limit t approaches to 1, it becomes 1 plus 1 into I, and plus, if I put 1 over here, it becomes 1 minus 2 over, and if I put 1 over here, it becomes 1 plus 2 into j. And plus of putting 1 over here, it becomes 1 plus 1 into e power t is 1, so it becomes 1 minus 1 into k. So it will give us 3i, and 1 minus 2 will give us a value plus into it will give us minus 1 divided by 1 plus 2 gives us 3 into j, and plus 1 plus 1 gives us 2 into e power 1 minus 1 gives us 0, and something to the power 0, e power 0 will give us a value 1. So e power 0 is equal to 1, so 1 multiplied 2 will give us 2k. So the required answer is 3i minus 1 over 3j and plus 2k. This is the required answer to the part number C. Now move towards the part number D. Limit t approaches to 0, find the value of t e power t over 1 minus e power ti plus e power t minus 1 over cos of tj. So we will directly apply the limit. So by applying directly limit, it will give us t e power t. So it becomes 0 into e power t, so t is 0 divided by 1 minus e power t is 0, I plus e power t minus 1, t is 0, so it becomes 0 minus 1 over cos of t is 0 into j. Now e power 0 gives us 1, 1 multiplied 0 gives us 0, and over here e power 0 is 1, so 1 minus 1 gives us 0, again indeterminate form in case of I. And over here it becomes e power minus 1 over cos of 0 is 1 into j. Over here I will apply t e power t over 1 minus e power t, so we can use limit L'Hospital rule. Over here these two functions are multiplied with each other, so according to the L'Hospital rule, we will use the product rule of differentiation. So first function t, derivative of the second function is e power t, plus second function is e power t, and derivative of the first function is 1. Divided by derivative of 1 is 0, and derivative of e power t is e power t, so it becomes minus e power t. Now I will apply the limit. So limit t approaches to 0, and over here we have I vector, and over here the value is plus e power minus 1 and j. Now over here I will apply the limit, so it becomes again, if I put t0, it will again give us 0, and over here if e power t is cancelled out with e power t, we are just left with minus 1, so it becomes minus I and plus minus I. Minus I and plus e power minus 1 can be written as 1 over e. So over here we can write it 1 over e into j. So this is the required result for the part number D. Now move toward part number E. Limit t approaches to 0, find the value of sin t by ti plus 1 minus cos of t divided by t into j, and plus e raised to power 1 minus tk. Now remember we have the property when limit t approaches to 0, the value of sin t divided by t will always be equal to 1. It is not necessary that the value of t will always be t. It can be anything. Let's suppose I take sin 70 divided by 70, and t is approaches to 0 over here. So the result will always be equal to 1. The necessary condition over here is this, that these two values must be same. Over here we have 70 and 70, so the result will be 1. Now by applying the limit at each and every term, so it becomes limit t approaches to 0, applying the limit on this term. So sin t divided by ti, and also apply the limit on the second term, so it becomes a limit of t approaches to 0, 1 minus cos of t divided by t into j, and also apply limit on this term, so it becomes a limit of t approaches to 0, e raised to the power 1 minus t into k. Now we know that limit t approaches to 0, sin t by t is equal to 1. So over here the value of this whole term will be equal to 1. So 1 multiply I will give us I, and plus if I put 0 over here, it becomes cos 0. Cos 0 gives us 1, and 1 minus 1 will give us 0 in the numerator, and t is 0 in the denominator. Again we have 0 by 0 indeterminate form. We will use the rationalization method over here. We will multiply the conjugate of 1 minus cos of t, so it becomes limit t approaches to 0. The conjugate of 1 minus cos of t is 1 plus cos of t over 1 plus cos of t. 1 plus cos of t, and over here we have t, so it becomes t into j plus applying the limit over here, t is 0, so it become 1 minus 0, it become e power 1 minus 0 into k. Now it become I plus 1 minus cos into 1 plus cos according to a square minus b square gives us 1 minus cos square t, which is equal to sin square t according to the trigonometric properties. So the whole value of 1 minus cos t into 1 plus cos t can be written as sin square t. So limit t approaches to 0. And sin square t can also be written just like sin t into sin t. Sin t into sin t, we just break this into 2. And in the denominator we have t into 1 plus cos of t. And over here we have j. And plus 1 minus 0 gives us 1. So e power e into k. It becomes e into k. Now over here it becomes I and plus of. You know that when limit t approaches to 0, the value of sin t by t is always equal to 1. So this whole term is cancelled out, it gives us just 1. We are left with sin t divided by 1 plus cos of t. Sin t divided by 1 plus cos of t. And limit over here is t approaches to 0. And over here we are left with ek. Now by applying t0 over here it becomes 0 divided by cos 0 gives us 1. 1 plus 1 gives us 2. So 0 divided by 2 gives us 0. We are just left with I plus ek. So this is actually the required and desired answer. Now move to the next part of part number F4. Limit t approaches to 0. Find the value of sin 3t over sin 2ti plus ln of sin t over ln of tangent tj plus t square k. Now over here if I put 0, it gives us sin 0, which gives us 0, and over here it also gives us 0. Again 0 by 0 indeterminate form. I will use this property to solve this vector function I. So I can write it just like a limit of t approaches to 0, sin 3t. I will multiply and divide with 3t over here in the numerator, and also apply the same logic in the denominator. Over here we have 2t, so divide with 2t, lie with 2t. Now after this, over here I will use, if I put 0, it gives us 0 by 0 again. I will use of El Hospital rule, differentiate this term and this term. So ln of sin t derivative will be 1 over sin t, and derivative of the inner function sin t will be cos of t, divided by using El Hospital. Ln of tangent t derivative is 1 over tangent t, and derivative of tangent t is secant square t. And also we have j over here, and plus it becomes a t square k. We will apply limit after. So over here you know that limit t approaches to 0, sin 3t by 3t gives us 1. And sin 2t by 2t will always be equal to 1 according to this property. So this whole term gives us 1. We are just left with t cancel out with t. We are left with 3 by 2 over here. 3 by 2 I. And plus cos by sin gives us cotangent. This tangent will move to the numerator. It becomes tangent t divided by secant square t. And we have over here j. And plus t square k. So this is actually cotangent t. Cotangent and tangent are reciprocal, they cancel out with each other. We are left with 1 over secant square t, which can be written as plus cos square t, and apply the limit. Limit as t approaches to 0, cos square t, and also apply the limit over this term. So limit t approaches to 0, t square k. Now by putting 0 over here, cos 0 gives us 1. So it will give us 3 by 2i plus j. And this term 0 square will give us 0, this whole term gives us 0. So the required and desired answer is 3 by 2i plus j. Now move toward part number G. Limit t approaches to 1, find the value of 2ti minus 3j plus e power tk. This is very simple limit. By directly applying the limit, it becomes 2 into t. T is 1, so it becomes 2 into 1i plus. Over here we have negative, not plus, minus 3j and plus e power t. T is 1, so e power 1k. So it will give us 2 multiply 1 gives us 2i, it becomes minus 3j, and it becomes plus ek. So this is actually the required result. Now move to the last part of today's lecture in question number 4, part number H. Limit t approaches to 2, find the value of 2i minus tj plus e power tk, multiply t square I plus 4 sin tj. Over here in the middle of these two vectors we have cross. So for the cross product or vector product, we use the determinant method. So over here it becomes a limit t approaches to 2. Over here these are the two vectors, so we will convert it into a single vector by using the determinant rule. So in the determinant rule we have three matrices. In the first we can write I, j, k. In the second we will write the coefficient of I, j, k. So the coefficient of I in this vector is 2. The coefficient of j is minus 2, and the coefficient of k is e power t. And in this matrix, in this vector, the coefficient of I is t square. Coefficient of j is 4 sin t, and over here we have no value of k, so we will suppose is 0. So after this, I can expand this determinant, let's suppose with 1. So expanding with R1. So for I will write I. Remember this sign for the 3 cross 3 order matrix, plus minus plus minus plus minus plus minus plus. We will use this sign. So over here we have plus sign, so we will take plus I into. We will cross those columns in which I lie and also those in which this I lie. So we are just left with minus t into e power t. And over here we are left with cosine t, and over here we are 0. So we will take the determinant over here. After this we have negative sign, so it becomes minus j. Now after this I will cross the column in which j lie and also the row in which j lie. So we are left with 2 into e power t into t square into 0. After this we have plus sign, so it becomes plus k. I will cross this column in which the k lie and also those row in which this k lie. So I will left with 2 into minus 2 into t square and 4 sine t. So after this, I will find the determinant of this matrix. So it becomes t into 0 gives us 0, and it becomes minus 4 e power t and sine t. And over here it becomes minus j into, it gives us 0, and it becomes minus t square e power t. And plus k into, it gives us 8 sine t. And minus into, over here it gives us 8 sine t. And the formula minus what multiply with minus 8 it gives us plus t cube. Now I take the limit on this whole expression. Limit is actually t approaches to 2. So by putting 2 over here it becomes minus 4 into e power t is 2, so 2, and sine time of t is 2. So minus 4 e power 2 sine 2i, and where it becomes plus so plus t square. So t is 2, so it becomes plus 4 square e power t is 2. So plus 4 e power 2j, and it becomes so 8 sine t. Sine is it becomes plus 8 into sine time of t. T is 2, so it becomes 8 sine 2 plus t cube. So t is 2, so t cube gives us 8. So 8k. So this is actually the required and desired answer, minus 4 e square sine 2i plus 4 e power 2j plus 8 into sine 2 and plus 8 sine 2 plus 8 multiply k. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC Part 2 Mathematics. Thank you.